All right, we're going to continue to work with the unit circle to evaluate trig functions at different angle measures. Now, as I go through this video, I'm going to actually not use the filled-in unit circle that you all should already have. I'm going to work on kind of building that unit circle to try to find these values. So remember, that's the goal, is to be able to replicate the unit circle and not have to refer to it as we work through this trig unit. Then it's going to take some time, okay? So I'll just kind of show some strategies for how we get there. A lot of what we're going to do today involves different identities or properties with the trig functions. Most of these will end up being provided to you. If there's ones that you need to memorize, I'll jot that down as we go through this, but I'll give you all of these identities when we're taking assessments, etc. All right. Um, so the first thing is just even odd trig functions. That's the same property that we talked about first semester with the function having even symmetry or odd symmetry. And so we can kind of work this out to prove these. We're not going to do that. We're just going to kind of use the fact that some of these functions are either even or odd, and that allows us to find values of cosine, sine, all of our trig functions. Okay, so cosine and secant are even, meaning they have symmetry across the y-axis, and then all four other functions, sine, cosecant, tangent, cotangent, are odd, so meaning they have symmetry about the origin. And again, don't need to memorize these, just things that we're going to go ahead and use. So in this case, when I recognize that cosine of negative pi over 4, what we want to recognize is, hey, we're taking cosine of a negative angle, and we know there's an even or odd property. With cosine being an even function, I can go ahead and say instead of cosine of negative pi over 4, this is the same value as cosine of pi over 4. Okay, and to be honest, we could find this value of negative pi over 4 on the unit circle. Granted, all of our unit circles have positive angle measures, so that's why this is a little bit more helpful here. But whatever cosine of negative pi over 4 is going to also equal cosine of positive pi over 4, right? So like I said, I'm going to go ahead and not just refer to my unit circle. I'm going to draw this in. Now, I know pi over 4, right? This is pi over 2 at the positive y. 0 radians. Pi over 4 is just the one that's halfway in between. Okay, so we've rotated pi over 4 radians. And in that kind of middle coordinate here, that's where we have the root 2 over 2, root 2 over 2. Right? So this is the goal, for you to recognize this. And yes, there's some memorizing involved, but again, if you can build this first quadrant, quadrant 1, where x and y are positive, you can use that to build all the others. Okay, so I guess kind of in a way we want to work on memorizing that first quadrant. Right, so remember that cosine of any angle is equal to the x coordinate on the unit circle, which is root 2 over 2. So cosine of negative pi over 4 is equal to root 2 over 2. And we use the fact that it's even, and cosine of positive pi over 4 is the same as cosine of negative pi over 4. Okay, so just moving along now with tangent being equal to this being an odd function. So if I have tangent of a negative angle, that's equal to the negative tangent of positive pi over 4. Right, so this is -1 times whatever tangent of pi over 4 is equal to. So I'm going to go ahead and think about what this tangent of pi over 4 is. Well, remember that tangent of any angle, so tangent of pi over 4 here, is equal to y over x. And in this case, I have root 2 over 2 divided by another root 2 over 2, and anything divided by itself is 1. And so this is really negative times tangent of pi over 4, which is 1, which is -1. So tangent of negative pi over 4 is equal to -1. Okay, why don't you go ahead and work out these next two on your own. Refer to the properties that you saw at the top there and see if you can find these values. I'll go over them in just a second. All right. So here in part A, secant of negative pi over 4, well, secant is an even function, so that is equal to secant of positive pi over 4. One thing we need to know and have memorized is that secant is the reciprocal function of cosine, so that makes it 1 over x. 1 over x being 1 over root 2 over 2, which means I'm going to flip the root 2 over 2. So it's 2 over root 2, and we need to rationalize the denominator, so multiply it by root 2 over root 2. And so we get 2 root 2 over 2, where the 2's divide out, leaving us with just root 2. And b, sine is an odd function, so sine of negative pi over 4 is equal to negative sine of the positive pi over 4. Sine of pi over 4 is root 2 over 2, so it's just negative root 2 over 2. Okay, we're going to continue along here and talk about some more properties. And the next property is called the reciprocal identities. These ones, I think, kind of help us make the connections between the fact that the reciprocal of sine is cosecant, the reciprocal of cosine is secant, the reciprocal of tangent is cotangent. Okay, and remember, reciprocal means to just flip it, right? So really, if we know that sine and cosecant are reciprocals, cosine and secant are reciprocals, and tangent and cotangent are reciprocals, coming up with these identities aren't all that difficult, right? So again, things that most likely provided, this might be kind of the ones that maybe we could have memorized. I'll go ahead and just say I'll provide them for now, and if we do need to memorize them, I'll come back and let you know later. The bottom ones here, called the quotient identities. Now, where this comes from, remember that tangent of any angle is equal to, one of the first things we learned with these trig functions is that tangent of t is equal to y over x. Well, if y is equal to the sine, or y is equivalent to sine of any angle, hence why we have sine up top here, and x is equal to cosine of any angle, that's how we get the cosine in the denominator. So it's derived from the fact that tangent of t equals y over x. And same idea with cotangent. That's x over y, where x is cosine of t and y is sine over t. Okay, so we're given the fact that sine over t is 2/5, cosine of t is root 21 over 5, and we need to find the value of the 4 remaining trig functions. So here's what I start out with. I first identify and think about, okay, if sine of t equals 2/5, that means that the y-coordinate for the point on the unit circle, or I guess in this case, we're not necessarily in the unit circle because of us getting these different values. But sine of any angle, we don't need to get a value that's exactly on that unit circle. Okay, it can be really any point along that circle, not just the ones that we've identified already. So the y-coordinate here is 2/5, and then given the fact that cosine is root 21 over 5, means that we have x. And so the next one I might work on is tangents. Well, tangent of t, and let's go ahead and use the quotient identity. It doesn't really matter here, it's y over x, right? That's sine of t over cosine of t. Well, using substitution, sine of t is 2/5. So this is 2/5. And then cosine of t, again, we're just substituting what cosine of t equals into this equation, which is root 21 over 5. And now we have to do the division here. So it's the top fraction times the reciprocal of the denominator. So 2 over root 21. And now this needs to be simplified. And there's going to be a decent amount of work to simplify these. So this is 4 over 5 root 21. We need to get that square root out of the denominator. So I'm going to multiply it by root 21 over root 21. So this is 4 root 21 times 5 times 21, which is 4 root 21 over, that'd be 105. And then we would look to reduce this down, although I don't think it's going to be reduced since 4 and 105, 4 is even, 105 is odd. I think that's as far reduced down as we can go, right? So tangent here ends up being a little bit more work. All right, now we need to find the other 3 trig functions. So the reciprocals of sine, cosine, and tangent. This is where we'll use the reciprocal identities to make it a little bit more straightforward. Hey, and remember, if we have sine, the reciprocal of sine is cosecant of t. Well, cosecant of t is 1 over the sine value. And another way to think about this, we know that sine is y, that's 1 over y. This is something that we should already know, right? That's one of the properties that I said we do need to memorize. Okay, so it's just another version of 1 over y, where y is equal to sine over t. Now, again, when it's reciprocal, we can just take the value at sine and literally just flip it. And I'll go and show the algebra for this one here. If I have 1 over 2/5, that's 1 times the reciprocal of 2/5, so 1 times 5 halves. which is 5 halves. So how could I have gotten that a little bit quicker? Just by simply flipping 5 over 2, right? So I'm going to use that idea for secant, where I know it's 1 over cosine of t, which is 1 over x. And so if I just flip this, I get 5 over root 21, which then needs to be rationalized. So root 21 times root 21, which is 5 root 21 over 21. And there's our value of secant. Right, and then the last value we need to come up with is cotangent. Now, cotangent being the reciprocal of tangent, I could flip this. When I flip this, I'm going to have to rationalize the denominator, and there's going to be a lot more simplifying to be done if we just simply flip what tangent is. So I'm going to actually take a longer approach here, and we're going to skip that example. And what I'm going to do is I'm going to use the fact that cotangent is equal to cosine of t over sine of t. Okay, that's the quotient identity that you have at the top of the page here, which is equal to the x-coordinate over the y-coordinate. So this is root 21 over 5 divided by 2 over 5. And so when I go ahead and do this division, it's top stays the same, multiply by reciprocal of the denominator. The 5's divide out, and I get root 21 over 2. Okay, so had you have flipped this here, you would have had to multiply. I'm sorry, you can't see that answer there. You would have had to flip this, multiply by root 21, and then reduce down the fraction. So it would have simplified to get to the same value. It just would have taken a lot more algebra than us just simply doing the division. And that's kind of what things we're going to have to pay attention to. Knowing what values we have and thinking about how the algebra is going to play out, and figure out what identity or what ways can I come up with that value to make the work a little bit easier. Okay, and it takes practice. Okay, it takes practice. It takes discipline. All right. We're gonna skip that checkpoint that I crossed out, and we're gonna just move on to a couple more identities. We're almost done here. All right. So one of the very first things when I introduced the unit circle was the fact that, well, and even just equations of circles, but the equation of the unit circle is x squared plus y squared equals 1. Right? When we wrote equations of circles first semester, so that should be somewhat familiar. And using the fact that cosine of any angle is equal to x and sine of any angle is equal to y on that unit circle, we can substitute in for x cosine of t and in for y sine of t, coming up with a Pythagorean identity of cosine squared plus sine squared equals 1. And we actually write it more, it doesn't matter, sine squared plus cosine squared equals 1 or cosine plus sine equals 1. Does not matter. Okay, both of those being squared. Right, so this identity gets used pretty frequently. These other two, not quite as much. And again, they're derived from very similar concepts here. These will almost always be provided. Let's go ahead and say to memorize this one, just because, again, this gets used pretty frequently. All right, so let's go ahead and put this to use. So it says, given the fact that sine of t equals 3/5, and t, so this is the angle, is between 0 and pi over 2, that tells us we are in quadrant 1. If you think about how much rotation we have between 0 and pi over 2, that's just quadrant 1. We need to find the value of cosine of t using a trig identity. So I'm like, okay, where do we even kind of start here? Well, we know that sine of t squared, and with this squared being there, that's kind of a weird place. The reason we put it there is because if I write it like this, you're like, okay, am I squaring the t or am I squaring the whole sine of t? And it's squaring the whole sine of t. Okay, so we're going to use that identity, cosine of t squared, which equals 1. Well, we already know what sine of t equals, right? Sine of t equals 3/5. So I don't even need to figure out what t is. I can just go ahead and square this. And then we have that cosine of t squared is equal to 1. Well, we're trying to find what cosine of t is equal to. And so our goal is to get this cosine of t by itself. So what I'm going to do is I'm going to square this 3/5. When you do that, you square the top and the bottom, right? Think about 3/5 times 3/5 is 3 times 3 up top, 5 times 5 in the denominator, and then plus cosine squared of t equals 1. So I'm going to go ahead and subtract the 9/25 over, and we're going to have to do some fraction work. So it's 1 minus 9/25. 1, by getting a common denominator, is 25 over 25, and then minus 9 over 25, leaving us with 25 minus 9 is 16/25. And so now, to get cosine by itself, right now it's being squared, we need to undo it by taking the square roots, leaving us with just a cosine of t. And when I square root 16 and square root 25, it's the same. We're squaring the top and bottom separately, getting us with 4/5. Okay. Now, one thing that we are given is that we're in the first quadrant, okay, in between 0 and pi over 2. And so basically that tells us that we're in quadrant 1, where x and y are positive, right? So when we square root, remember that it could be plus or minus. And so this bit of information is more for us to decide, okay, do I want positive 4/5 or negative 4/5? Well, being in quadrant 1, it needs to be 4/5. Okay, so that is our answer there. All right, again, we're going to skip this checkpoint and get to our last properties. There's a lot of information here. We'll just kind of talk through it real quick. And this is actually going to be something we focus on as we start to graph these functions. So sine, cosine, and really all of these functions are called periodic functions. And so certain patterns in nature repeat again and again. For example, the ocean level at a beach varies from low tide to high tide and then back to low tide approximately every 12 hours. Okay, that's a word for that is oscillating. Okay, so just repeating over and over again. A function that repeats over and over again is called a periodic function. Okay, so a function is periodic if there exists a value of p such that if we add that value of p, we get back to the same point. Okay, so that's just saying, basically this is the math version of saying repeating over and over again. Okay, by plugging in the same x value or different x values, we get the same y's. Now, the reason that's important is because sine, cosine, and really all of our trig functions are periodic, meaning every time we travel full 2 pi, we get back to the exact same values. This is the same idea as coterminal angles, right? Where coterminal angles can have the same position, but maybe different rotational amounts. Okay, that's what this is showing, right? And for now, we'll just, again, provide this to you. When we start to graph, this will make a little bit more sense. But basically, if we want to find sine and cosine of higher angles, we can basically find the coterminal angle and come up with that value. Okay, that's what this is saying. Okay, and sine and cosine, they repeat every 2 pi, right? Okay, like sine and cosine, secant and cosecant functions have a period of 2 pi. However, tangent and cotangents have a smaller period. Tangent and cotangent have a period of pi. Okay, so that's going to be a little bit different when we're working with the unit circle and finding values of tangent, and then also with the graphs. But that's just me saying that it repeats every pi with tangent and cotangent. Again, we'll provide these for now. We'll work on memorizing and using these things a little bit later. All right, last thing is just saying that it doesn't only repeat just 2 pi, but it can repeat in increments of 2 pi. Okay, so accounting for multiple rotations around the unit circle. So 2 pi, 4 pi, 6 pi, 8 pi, etc. So every value of n is adding another rotation around our unit circle, right? So that's what these last ones are showing here. Okay, so if I want to find the value of these trig functions, a good place to start is, what do we know about 9 pi over 4? Well, 9 pi over 4 is more than 2 pi, right? If I take 9 divided by 4, that would be what? 2 1/4, so 2.25 pi. So what I might do is I might break down this 9 pi over 4 by subtracting 2 pi from it. And so that's 9 pi over 4 minus 8 pi over 4, which is just pi over 4. And so in the property, what you're going to see this written as is sine of pi over 4 plus 8 pi over 4, right, which is still 9 pi over 4, right, pi over 4 plus 8 pi over 4, is equal to just sine of pi over 4 because of those being coterminal angles, right? That's all this work was. was me identifying that 9 pi over 4 and pi over 4 are coterminal. So what is sine of pi over 4? Well, again, building my unit circle, I know that pi over 4 is that middle radian, where the coordinates are root 2 over 2, comma root 2 over 2. And this is the y coordinate, which is root 2 over 2. And that's it. All right. Well, same idea with tangent here. With this being negative, we could use the fact that the even-odd identities, we could even go ahead and add pi or add its period. Okay, so how often it repeats to figure this out. Let's go ahead and just use that periodic idea and say that negative 5 pi over 4. In this case, we're going to add pi because of the fact that tangent repeats every pi radians to go ahead and find this value. And we're going to do it until it becomes positive. So I'm going to add 4 pi over 4, which is negative pi over 4. And I'm going to do that one more time. So I'm going to add another pi, or 4 pi over 4, which is 3 pi over 4. So really, I'm finding tangents of 3 pi over 4, and then we're subtracting away the 2 rotations that we added in. So we're minusing 2 pi technically, which would be 4 pi over 4, 4 pi over 4, 8 pi over 4, which is just equal to tangent of 3 pi over 4. Okay, well, at 3 pi over 4, now we're in quadrant 2. Right, so here's how I can kind of use what I have down with my first quadrant here to figure this out. Well, pi over 4 is a quarter turn all the way to pi. Right, so that's a quarter turn. If I go to another quarter turn, I get to pi over 2, or 2 pi over 4. Okay, that's equal to pi over 2. And if I go one more quarter turn from there, that's where I get to 3 pi over 4. Okay, which is root 2 over 2, comma root 2 over 2. But one thing we need to consider is that in quadrant 2, x is negative. So this is a negative x value. And so our value here is negative root 2 over 2 divided by root 2 over 2. And this is still anything divided by itself, which is 1, right? Root 2 over 2 divided by itself is 1, but now it's just negative. So it just equals negative 1. Now, again, you could have taken a whole nother set of ideas to get to these values. Okay, you could have used the fact that tangent is an odd function, and so you could have also said that this is equal to negative tan of 5 pi over 4, and then you could subtract away the rotation of pi, and then find negative tangent of pi over 4, which of these values right here, and then that would be 1 times the negative is negative 1. Okay, so lots of ways of how to use these properties, and you're going to have to be willing to try some different things and be creative. Okay, so use those properties. That's why these notes were printed off for you. Okay, why don't we go ahead and do A and B here. I'm going to just pause the recording just so it's not all that long. I want you to pause as well and work through A and B, the answers once you pause it. All right. Here's what you should have came up with for cotangent of 5 pi over 4. That is just equal to 1. So I just broke down, I subtracted away 1 full period from cotangent, which again is pi. So I'm subtracting away pi, which is 4 pi over 4, getting me to just pi over 4. So cotangent of 5 pi over 4, where 5 pi over 4 can be written as pi over 4 plus pi, is simply equal to just cotangent of pi over 4. At pi over 4, we're taking y divided by x because of it being cotangent. Y divided by x is just root 2 over 2 divided by another root 2 over 2, which is just 1. Right, and then in part B, I went about it a little bit differently than what I had done B previously. This time I used that even-odd identity with cosine being even, so cosine of any negative angle is equal to cosine of that same positive angle. And so I'm like, okay, I'm really working with cosine of 9 pi over 4. So then I went ahead and took 9 pi over 4, subtracted away 1 rotation, finding that coterminal angle. 9 pi over 4 minus 2 pi, or 8 pi over 4, is pi over 4. And so really, cosine of 9 pi over 4 is equal to cosine of pi over 4 plus 2 pi, which is 1 full rotation, and simply equal to just cosine of pi over 4. At pi over 4, both coordinates are root 2 over 2. Cosine is x, so that is root 2 over 2. Right, you have a math Excel to work through this. It is going to take some time. It is going to take some practice. Okay. And we're going to get plenty of it through the Math Excel and also some work we do next week. All right. Have a great day.